So hey, and welcome to Plutus PBL live coding. It's the 1st of September, and I still have teaching in my blood, so I feel very energized when September hits every year. It's a great time of year, and the temperature is about 15 degrees cooler than yesterday here. So just that learning vibe is in the air, and it feels really good to be here. How's everybody else doing? Welcome, welcome.
Good, James. Good, James.
Hey, man. Happy early morning.
Yes, sir.
Is the house emptied out yet, or are people still kind of getting ready for the day?
I'm getting my kids dressed right now, getting them ready to go to school.
Legend. Love it. I've been thinking a lot about all the stories we're going to tell about the things we were doing concurrently with learning Plutus and starting to write dApps. I think there'll be some good tales to tell. Well, for anybody who was here or not here yesterday, we had a nice chance to kind of hack away and really start to understand how multi-sig transactions work. I think if you worked through the minting modules earlier in the course, you had a chance to see how a multi-sig minting policy works. But there were a few things that I hadn't quite understood about what it takes to build a multi-sig transaction for a multi-sig address. And it has a bit in common with a contract address. So one thing I didn't know is that if you want to unlock a UTXO from a multi-sig address, you do have to include the script file that was used to derive that multi-sig address. And so I'm happy to understand that now. And this matches what we have to do in Plutus. If I want to unlock a transaction from a Plutus contract address, in the very same way, I would follow the UTXO from the contract with a Plutus script. And then the difference being that for Plutus, I would also have to include here, a redeemer and a datum hash to unlock. Okay, so, and we'll look at that today. We're going to play with the faucet contract today on Cardano CLI. I want to show you a bug I ran into that is obvious in retrospect, but I was trying to take an easier approach getting it started. And I found out why that wouldn't work. But what we're going to do is we can look at the Plutus faucet contract. We can look at the functions that it uses and take a look at the documentation as well, because that's something I want to really practice with everybody. And then if there's time, I'd like to give anybody who has a pre-production testnet node running, I'd like to give you the chance to try to unlock some test gimbals from that contract on Cardano CLI. So that's the plan for today. Before we jump in, any questions following up from yesterday about unlocking funds at a multi-sig address? So I've been, I'm going to switch over to my terminal for just a moment. I've been messing around on Preview today, trying to start writing some lessons about transitioning from V1 to V2 of Plutus. And that's another thing I'm really excited about with the faucet contract, is it's going to give us a really nice context for thinking about that. Oh no, I am running pre-prod, right? Okay, I already switched. Good. So yeah, I'm on the pre-prod network, but everything we do today with this faucet contract that is currently written in Plutus V1 is going to set us up to, in the upcoming weeks, revise that contract and build some Babbage era transactions on the preview network. And that's going to be fun. What's interesting about the change from V1 to V2 is actually the Plutus is not going to change very much. There's only a few minor tweaks we're going to have to make to our Plutus code. But then after we compile a Plutus script in V2, the rules about how to use it in building a transaction are completely different. And so that's really where the big change happens, is not in writing the logic itself, but in using the Plutus script once it exists. And so as we go through today's lesson, I want to really be actively setting us up to start thinking in terms of V2. So I should be able to query my node here. I have just a couple of scripts here. So, you know, when I run this script, this is all it's doing. It's setting my node socket path, and then it's querying the tip of the network I'm on, which happens to be pre-production here, network magic 1. So when I run .101, I can see, okay, we're on the Alonzo era, right? The pre-production network, unlike preview, hasn't forked yet. So we're still in the pre-Babbage, pre-Vassal, pre-Plutus V2 era when we use the pre-production network. And as you can see right here, I'm synced up and ready to go. So that's what we'll use. I have a couple of wallets here. And so I'm just going to start to drop a couple of variables in here. This is wallet 1 on pre-production, and now I can say Cardano CLI query UTXO testnet magic 1, and then the address wallet 1. And there's all sorts of stuff in this wallet. But this looks like a lot of UTXOs, but basically what I've done for myself is just made life easier moving forward by splitting up a bunch of UTXOs. I started with 1,000 ADA from the faucet, and then I broke it up into some smaller transaction, you know, some 10 and 5 UTXOs here. This is really good to have for fees and for collateral. And then I have a bunch of UTXOs that just have one PPBL summer 2022 token in them. And then I have a couple other UTXOs that have some test gimbals ready to go. So first call to action here, in order to interact with this contract in the first place, you're going to need one of these new PPBL summer 2022 tokens on pre-production. So do me a favor, if you want to participate actively today, just drop in the Zoom chat your pre-production receiving address, and then I'll build a transaction that sends a bunch of these PPBL summer 22 tokens out to everybody who's playing along. Take your time to do that. We'll get to that in just a minute. But while you're there in the background, drop me an address if you want one of these right now. Any questions so far?
So the difference between the pre-production and the preview testnets are that the preview is already up to Babbage and the pre-production is up to Alonso?
That is the most important difference, yes.
And how do you have it set up? So you downloaded 2 nodes and you just have a variable script that you run that changes the socket path? Is that how it's set up?
Yeah, watch. So I've got this one right here, Cardano node run, that points to a certain topology file. And I downloaded this from that link that's been going around, I forget, IOHK world, and it's got the different sets of configuration files, right? So I've got one directory called testnet config pre-production, where I have those 7 files for the pre-pro network. Now, the only ones I actually reference when I run Cardano node run are config and topology, but the config file does point to some of those other files. So, you can't get away with just downloading these two. You do need those other Genesis files.
Yeah. Yeah. Okay. Yeah. Perfect. Perfect.
And then
Thank you.
same way, I've got, and I just use the numbers to make it easier to autocomplete, right? But then this one here, I got a different directory for preview files, and same thing.
So what was the node socket command that you used?
Okay, then for each of these, so like 100 for me is pre-production. That's arbitrary. That doesn't matter that much, right? Whoops, let's cat that. So this one says just set the node socket to that DB folder that's specified up here, and then query the tip on testnet magic 1 versus 201 would be my pre-production, and that just points to a different DB, and then it specifies the other testnet magic.
So it's just a matter of really downloading another testnet node and just setting it up, right?
Those different sets of configuration files. Yeah, you can write, once you have Cardano node, and at this point, I'm personally only using 1.35.3. I know that 35.2 would allow me to interact with the old testnet, but I'm just choosing to ignore that and to kind of move forward with these tools as they are.
Yeah, me too. Okay, perfect. Thank you.
You bet. And then just to show you, I've got 0.0 as well, right? So this is my mainnet start node that points to just the mainnet topology, mainnet config, and that DB. And then of course, this one, you don't need to specify testnet magic, you just say mainnet. And once again, good to go.
I like the number systems, the 0s and 0 and 1s for testnets and different types of testnet. That's really cool.
Roberto Morano taught me that. Yeah, just use numbers for autocomplete when you're playing around in Bash, and it just saves you a lot of headaches later. You have to memorize your system, but I think I can remember 0, 1, and 2, at least for now.
Yeah, that's very useful.
What's up, Dominic?
Oh man, that's awesome. So just to clarify, I can keep my 1.35.3 build and just change my topology, and I'm golden. Bro, I'm in the game. Love it. Thanks, man.
Change all 7 files. All 7 files.
I will.
Yeah.
I'll change all 7. I'll create separate directories for the node I'm going to run. Fantastic. Thank you much.
Yeah, man. And so there's other differences that in practice don't matter as much to us, but it's good to think about. So preview network actually has a shorter epoch length. I think it's just 1 day per epoch instead of 5, like mainnet and pre-production. And that just allows for faster testing of stake pool operations and anything you might want to do with epic by epic staking. So that changes there. And the reason I mention that is A, just so you know about it, but B, the future is coming. And without going too deep into what Hydra is, it basically allows you to run a instance of a Cardano network inside of a smart contract. And what this means is that all of us who choose to do this, right, once we start playing around with Hydra, you're going to be able to set network parameters and then run networks as needed. There's already an organization called Shares Lake, maybe you've heard of it, and they are running a Cardano network. They're using all these tools that have been built, but they defined all of their own network parameters. And if you want to use their network, you need their configuration files. And now you are running a different instance of Cardano for this private purpose. And that's just, I think it's worth reminding each other that that's what's possible. We talk about Cardano as a monolith, but really it's a protocol that can be used and reinstantiated for a world of purposes, which that blows my mind when I start to think about that. Ooh, we got Hydra challenges coming in Fun 10. Yeah, we might have to do a little experiment with that. That'll be fun. I'd like to watch that. I'd like to watch that. Thanks, Lucas. Curtis.
And sorry if you already covered this. I was absent from my phone for a second. So you have a separate directory for your topology, or basically all your config files, and then a separate directory for your node socket. When you're bouncing back and forth between preview and pre-prod, are you also creating a separate DB directory? So, or can you utilize the same DB?
Great question. Who wants to give a try answering that one? Dominic, what do you think? You might be muted if you're talking, I'm not sure.
Sorry, you'd have to use different databases. I would say because they represent different chains with different blocks on them, so they would need to be different.
That's right. Yeah, so each of these DBs is in a different folder because whatever is on pre-production represents a different chain of transactions than whatever's on preview versus what's on mainnet. All right. I have an address from Sebastian so far. If you have a pre-production node running, just drop me a testnet address in the chat and I'll be sure to get those summer 2022 tokens out. But let's take a look at some Plutus code for a couple of minutes. I actually pushed these changes. Let me make this a little bigger. I pushed these changes to the PPBL course 2 repo this morning. There is now a directory for the faucet on Plutus v2, but it's just a placeholder for now. I haven't made the changes yet. That's just there because we're going to start moving, playing around with what it means to change from v1 to v2. But I'm going to go into this project 301 faucet directory. This is live. You can pull down these changes if you have this this repo running. And I want to look at the faucet validator. Now you can see right here, I have a couple of versions of the faucet validator because I've been playing with a few options, and my goal at all times is to try to like put situations in front of you that allow you to kind of tinker around and figure stuff out. So this is the first version of the faucet contract. And just to wrap our minds around the logic, this is a parameterized validator. It takes an integer as the datum and as the redeemer. And there are these 5 guards set up right here that we want to check for. And this, I'm just reviewing what's already been covered in module 301, what's up there so far. And we actually built some successful transactions with this contract a couple weeks ago. There's a live recording video of that. I'm happy to review any of this, so please stop me if you have questions about what you see here. But what I want to focus on today is this bit right here. What I was doing in this contract, let me just silence that. What I was doing here is I was thinking, okay, well, we want to make sure that the person who's pinging this faucet gets back their access token, the PPBL summer 2022 token. And we want to make sure that they get the tokens that they're trying to withdraw from the faucet. Now, these are optional guards. You know, we could almost argue that for a faucet, if we're letting people pull funds, it's on us to create transactions that provide those for people. So it may be the case that this logic is even a little bit redundant or unnecessary, but the point is I want to play with Plutus. And so that's really what we're trying to do, is just show how this works And you can decide for yourself what guards are necessary when you're opening up an opportunity for people just to take funds. If I go down and look at each of these functions, output has access token and output has faucet token. This is the logic, okay? So this one, output has the access token, returns true, as long as what the receiver gets back is at least one token. And the reason I used greater than or equal instead of equal is that it may be the case that somebody has a UTXO with multiple access tokens in it. And if they do, we wouldn't want this validator to fail or penalize somebody for having multiple access tokens, right? As long as they have one or more, we're good. In most cases, people are going to have one access token, but at least, again, if you end up with more than one, or I have a bunch in my wallet just because I'm still giving them out, I didn't want to get tripped up just by virtue of having too many of them. Then we've got the output has the faucet token. This is the same logic. You can see right here. These look pretty much the same. It's just that here we're checking for the access token symbol and token name. And here we're checking for the faucet token symbol and token name. And in this case, that has to be greater than or equal to the specified amount. So where is this amount specified? So this is where we get to start really thinking about how Haskell works. Faucet is a data object. Here it is. This is called record syntax in Haskell. One of the benefits of record syntax is that when you write it like this, the order doesn't matter. Okay, so I can place these parameters in any order and it'll be equivalent. The other benefit of record syntax is that when I use it, a set of helper functions are automatically generated. And understanding this concept is going to make it easier for you to read Plutus documentation, as we'll see in just a minute. But what do we see here? Well, the faucet params are used as a parameter in this validator. In module, I think it was 204, sorry, got my numbers mixed up. Jonty did a really good job covering how validator parameters work, and we're going to continue to see this in practice. So for now, I'm not going to go too deep into the use of parameters, but we are going to continue to use this. What I want you to notice for now is that anytime we have a type signature in Haskell, and we say, okay, this function takes this and this and this and this to return this, we can then instantiate each of those and just give each of them a name. So as we're using the faucet parameters in this validator, we're going to refer to them as faucet. As we refer to script context, we'll use CTX. We're not even going to refer to the datum and redeemer here, so those can just be anything. We don't care. Now that faucet is specified, we can use that over and over again down here, right? So the only reason on line 75 and 81 and 84, anywhere else? Yep, and down here on line 105. The only reason I'm using the word faucet right here is because I used it right here, right? If I changed this to banana, then I would have to change all of these to banana. The helper function that's provided is this pattern right here. I can say, give me the access token name from faucet, and I get whatever was in this parameter. Give me the withdrawal amount from faucet, and I get that integer. Roberto.
Could the faucet params, the data record, could that just as well be a datum? Could we just as well define a datum with these type of parameters and use it? Okay.
Yes, sir. Yes. Okay. So 100% absolutely yes. First of all, you would define the data the same way. So this data type that's been created here can be used as datum. You would have to add a line instead of using Plutus TX make lift. You would have to use another Plutus TX function called make unstable is data. And you're going to see that in just a moment. Okay. Yes. Now, the design problem of deciding when data should be captured as a parameter versus as a datum, that's a really interesting one. And anybody who ever builds on Plutus is going to have to be able to weigh the benefits.
Yeah.
When do I want to parameterize this thing versus when do I want to use datum? And yes, so I just coming attractions, I would love for anybody here to try to rewrite this contract without parameters and that only relies on datum. I think that's a really, really good exercise.
Okay. Awesome.
Yeah. Dominic.
Yeah, I wanted to ask about the currency symbol, token name, currency symbol, in the obviously integer when you're doing the type up at the top when you're actually, yes, correct. Now, are those predefined functions from Plutus or, you know?
Yeah. Yeah, so token name and currency symbol come as part of Plutus. And then even integer, I got to double check on this, but you see up here, we're importing Prelude, which is the Haskell library. And then we're also importing Plutus TX Prelude. And I got to double check. I forget if this is a unique version of integer that's provided by Plutus, or if this is just the Haskell integer type. And if anybody can double check on that, I would love to just have a clearer answer to that right here. But yeah, these ones are obvious. They come with Plutus.
Thank you. That's good for me because sometimes I'm like, what I struggle with every once in a while is, hey, am I creating the names or am I using the predefined? And I feel like once I understand that these are predefined and they have helper functions, as you so rightly pointed out, that's going to help me know how I can flex it. So that's really helpful. Thank you.
You bet. Awesome. And actually, we're just reading the comments here too. Like I agree, right? Faucets are one thing, airdrops are another, and writing contracts that would facilitate an airdrop in some way, that's another exercise we might want to do. And so I wanted to do this faucet project more from the perspective that I think it's a great way to learn how some of these tools work. But I reserve my opinion about whether it's the best effective option for a given outcome. Let's head over here. I'm gonna just open up the documentation for a few minutes. Now, anytime you're in any of the Plutus documentation, this quick jump button right here gives you access to all of the documentation. So for example, if I wanted to learn more about currency symbol, I could just start typing that. And even if I have a typo right here, it kind of tries to figure out what I'm talking about. So there we go. All right. And so here's the currency symbol constructor. And then where is the type? Here's the type currency symbol. And you could read about that. It's right. It has some of this basic Haskell stuff. We're able to test for equality among currency symbols. We're able to sort them by order. We're able to show them, etc. And then we have a bunch of related functions that we can use. There were a couple of other functions that I started using. So here's one example, script context info, right? And I can see, okay, that's an example of something where there's a V1 version and a V2 version. All right, so once again, how do is there a dark mode button in Brave that I can switch this for you? Right, so once again, let me just type currency symbol again. Right, and so currency symbol is another one where there's a V1 and a V2 implementation, and you would see this is where I would have to change my imports. Ledger contexts, ledger API, I would have to switch those. There's other functions like symbols, where it doesn't matter, right? There's just, this is a V1 function that will actually still work on V2. And so let's take a look at this one, because this is where reading the documentation, I think, gets really interesting. I want to read this function right here. First of all, what does this function do? Well, the type signature says it doesn't take any inputs. And all it does is it outputs a list of currency symbols. So how do we get that list of currency symbols? Well, we run this logic right here. And it can be, one of the things I've found that's challenging to read this is that I have an easy time losing track of which functions here are built in from Plutus and which ones I might have written elsewhere and defined myself, right? So this symbols, value spent, info, that fine, I can read that. Symbols, was that built into Plutus? I guess I could search the documentation. Value spent, well, I don't see it anywhere else, so I guess that was in the documentation. But info, oh, okay, right, I defined that up here. So that one is just defined by me, right? So I like just situating myself first when I read one of these and figuring out where I might want to read some documentation. All right, so what does this do? This says symbols, $, value spent, info. If you don't know this about the $sign yet, it's equivalent to writing this. Okay, so I could write symbols with what as the input? This right here. And there's absolutely no difference in use between writing it this way versus not using those parameters and just putting a $sign here. Sorry, those parentheses, and just putting the $sign here. You'll hear people say in different Haskell instruction, it's just a matter of taste. Personally, I use both. You see down here, I'm using parentheses. And actually, I got a note that says they're redundant. I don't have to use those. I still use parentheses just because it helps me think better. Okay, and that's one of the things I know that it can be hard about Haskell, is that when you see when you see just this very elegant code written right here, it can be tough to understand the exact logic because grouping is not always obvious. So I'll add parentheses like this just to remind myself, okay, we're doing is this an element of this. But what we can see here is that all tokens is equal to symbols, and that takes this parameter, value spent, info. So I'm going to drag back over. The screen's about to get bright white again. Here it comes. Okay, in the documentation, what's the type signature for symbols? Well, it says that symbols takes as input a value, and it returns an array of currency symbols. That's good. That's what I want to see. If I'm going to write that some function must return a currency symbol. Well, that must be, I'm going to get a compiling error if this right here doesn't return a currency symbol. And so I really want people to just, if you haven't gotten comfortable with reading the Plutus docs, this is such a great way to practice, is just read those type signatures and say them out loud to yourself. All right, I'm writing a function that takes this as input and that as output. Is that the output I said I was going to have? Okay, good. And if not, don't be surprised when you get a compilation error. Now, the good news is when you do get a compilation error, it's going to say, hey, we expected this data type, but we saw that data type. And that's helpful too. So when you go back and forth between trying to write something that works, reading the errors that you see, and then checking against those errors in the documentation, I think you can pretty quickly build up an intuition for how these functions are put together. Now, that's just part of the story. Symbols returns a currency symbol. I feel good about that. What does it take as input? A value. Well, am I sure that I am passing a value to this symbols function? That would be a good thing to look up in the documentation as well. If I'm doing this right, what I expect to see when I look up value spent in the documentation is that it returns a value. So let's go confirm that. Back to the docs. Just going to scroll to the top of the page and quick jump to value spent. And right away, I can see without even clicking through, oh, good, that does return a value. That's what I was hoping to see. And once again, right, so I get a little information here, get the total value of inputs, of all the inputs, okay, spent by this transaction. So value spent takes a TX info, the whole TX info, everything, right, about the transaction that we're trying to validate, and it returns the comprehensive value of all the Lovelace and other tokens in that transaction. Cool. And so now, of course, if I go back to my code, I'm happy to know that value spent returns a value. That's what symbols needs. And value spent should take a TX info as input. Let's confirm that in the code. Right? And that's why the $, remember, is just like putting parentheses around this. So this is the function value spent with info as an input. What was the type of info? It's exactly what that type signature said it should be, TX info. Pause here. I'm gonna do this kind of walk through a bunch of times over the next few weeks, but I just really want you to have this kind of intuition. Hey, what do you think? I think you're muted.
Check. Can you hear me now?
Yeah.
Okay, cool. Sorry. Yeah, just a quick question. So that the value that one returns, would that include the transaction fees or not? Just a quick.
Ooh,
Yeah.
Great question. So you're saying this TX info right here, what's encapsulated in it? Perfect. Next question. Okay, let's look at that in the documentation. And before we do, remember this record syntax right here and how I was saying that it provides for you right out of the box a whole bunch of constructors. That's going to be relevant in just a minute when we look at TX info, because TX info is also a record. And it's got a bunch of different stuff inside of it. So I can just click on that to find it in the docs. And here, notice, this, I hope that what's shown here in the documentation, I hope you can see how this is similar to that faucet params record syntax I was just showing you, right? Faucet params has, I don't want to give anybody whiplash. I'm going to switch back and forth a couple times, right? Faucet params has these with a type declared for each one. TX info has these with a type declared for each one. Additionally, notice in both cases that this data type that we're creating is capitalized, and each of these record fields inside has a lowercase letter in front. When I do this, once again, now, just like here, and actually I can show you an example of this right away. Just like I'm able to type withdrawal amount faucet in my Plutus code to get the withdrawal amount out of that faucet record, I could type something like TX info signatories in the TX info to get those. And that's what we're going to see right over here, for example. When I try to get the pub key hash of the person interacting or the wallet interacting with this contract, I follow the exact same pattern as I did here with access token name faucet, right? TX info signatories info, which is just my name for the TX info that we're dealing with. So to your question about fees, is that one of the fields here in this record? Yes, it is. One thing that's interesting to me about TX info fee is that the data type of it is a value, not just Lovelace. So what does that open the door for? Think about Plutus and think about the fact that Cardano is a protocol that can be reinstantiated by anybody. Part of what's awesome about this is, hey, if you create your own instance of Cardano, you can set the fees to be denominated in whatever tokens you want, right? It's a value, not pointing to any
Babel
particular
fees.
token, right?
Nice.
Other questions about what you're seeing right here? Justin's question, is there a difference between Plutus V1 value spent and Plutus V2 in the documentation? Let's go take a look. So yeah, let's look at value spent, which is an example of a function that exists in both ledger.context, right? Both eras of Plutus. So right here, it just says value spent, takes TX info, returns a value. Now let's look for the same thing in V2. And we can see that actually in the documentation, there's no difference whatsoever. What we're going to see as we take this faucet contract and rewrite it for V2 is that basically all you have to change are the imports. I want to qualify that. We might find like a handful of exceptions, but the actual logic, this part right here, where I'm just writing validator logic, there will be no change to this. We're going to just change which version of Ledger, for example, we import, because when it's compiled down to a Plutus script, V1 is going to create a Plutus script that can be used by one set of rules when you're building transactions for it. And V2 will compile the same validation logic, but into a different package that can then only be used by those transaction building rules that come along with V2. And here's the other thing. The use cases for V1 will not disappear completely. And this is an idea that we might come back to later on. But at a very high level, if you want to have a Plutus V2 script, you must first add that script to the blockchain before you can then start interacting with it. And I'm imagining that for some limited use cases, right, that might not be used by thousands or millions of transactions or whatever, maybe there will be some cases where you want the V1 version of contract interaction and transaction building. I might be wrong about that, but I'm just speculating like, hey, I'm going to keep my eyes open for reasons to use one versus the other. All right, well, we were just looking at actually the TX info. Oh shoot, was I sharing my screen when I showed those differences between V1 and V2? I'm sorry if I wasn't. I'm happy to go back. I think I just did a demo and was sharing.
We're just seeing VS Code.
I'm sorry, let me do that real quick, what I just did, sorry. I'm in the V2 docs right now. And what I did is I just showed that value spent, right? The signature is the same for each. And if I click on the V1 version, I see this. And if I click on the V2 version, I see the exact same thing. Okay, so the documentation for this function, as well as almost all Plutus functions, is unchanged from V1 to V2. It's really just about the transactions that each is spitting out. All right, so I want to tell you about the problem I encountered. We've tested this. There's a video, like I said, from a few weeks ago of live coding where I showed you how to build some basic transactions and test this contract. We locked some funds, we unlocked them. But when I started testing this, actually, let me rewind a little more. I then added this to the front end template. And there's a placeholder there. The logic for interacting with this contract is there in the front end template on a page called faucets. So if you have that template on your device, you can go take a look at it. But just as we were really rolling on that, all the testnet stuff went down and just kind of been waiting mostly for the third-party tools to make that possible to use again. We need to be able to query a contract address and get the UTXOs there. And once testnet was out of commission, there was a little bit extra work to do there. But that was a good thing because there was an issue kind of hiding that I couldn't have seen otherwise. I got this thing working with Nami wallet in the front end template, and it was great. We could lock some funds, we could unlock them, whatever. When I then tested it with Eternal, even, right, Lucas, I see Lucas's note in the chat about enabling single wallet, okay? Even with a single wallet in Eternal, it still derives multiple addresses. And anytime you have multiple addresses created, it gets a bit more complicated to know which particular address is associated with the inputs to a transaction and is therefore signing those away in the transaction, and then which ones are where the outputs are going, which we can specify in our front end. And this right here was the problem for that. Okay, so what is TX signatories info? We were just looking at that record of TX info, and the data type for TX info signatories let's just look at it together again. TX info signatories is an array, or array is not Haskell, a list of pub key hashes. And so I have some super lazy code here. I said, well, with a single address wallet, there's only one pub key hash I have to worry about. So just, this is a Haskell function right here. Take the head of that list, take the first one. And in a list of length 1, it doesn't matter, right? I'm just lazily getting the first and in most cases only pub key hash in that list. But as soon as we start talking about multiple addresses, this lazy approach doesn't work anymore, right? The PKH I need might not be the first one in the list. And so with this code right here, I couldn't get this thing to validate when I was interacting with it with eternal. And so that set me to start thinking about, okay, what can we do instead? So let me pause here. Does anybody have questions or comments about that problem that I'm identifying here?
So you're talking about what we were just talking on the chat, that I was suggesting that we always enable single wallet, and what you're preparing us is not to have to do that, and we can handle the real world.
Right,
Yeah.
exactly, right. I
Cool.
mean, yeah, it's one thing to kind of like put ourselves in a sandbox where we never have to worry about this problem, but exactly, in the real world, we can't ignore that that's an issue.
Cool, thank you.
Yeah. So I got this receiver pub key hash. And, conveniently it works when the list of pub key hashes has only one item in it. And then what did I do with that? Where else do I see receiver PKH? That's used here. Let's take a quick look at this function, value paid to, because it's an important one. So I have a helper function called value to receiver, which, as you can see, is used here. We'll get to this in just a moment. Value to receiver has a signature that says, okay, this should return a value. And how do we do that? There's a Plutus function called value paid to. Now try to imagine what the type signature of value paid to is going to have to be before we look at it in the docs. How many inputs do you expect to see when we find this in the documentation? There they are.
At least 2.
Right? TX info. Yeah, Roberto's got it. And a pub key hash. And then what's the output going to be? See it here. So I hope people aren't surprised. If we look this up, we should see that value paid to, we'll see an arrow, TX info, arrow, pub key hash, arrow, value. Let's see if that's true. I'm going to do a quick jump. Value to, oh no, that's the one I wrote. Sorry. Value paid to, and indeed, that's exactly what the signature says, right? We can read about it by going in, but the signature is exactly what we expected. And what does this say? Get the total value paid to a particular public key hash by a pending transaction. So earlier we have this value spent function that gives you the sum of all the value in some transaction. And then value paid to allows us to start breaking that value into different sets based on who's getting what value out of a transaction. Hey, Roberto, that's good news. Cool. Okay. And the way we figure out who's getting what is we provide a PKH and we say, okay, well, you got all this value in that transaction. I just want to know which value is going to whatever pub key hash I specify. And then once we have that written, now we can say, okay, let's look at that value. And let's find the value of within that value something else. So same idea. Let's go look up value of in the documentation. What's the type signature of value of going to look like? How many parameters do you see here? See them? A total of 3. Value of takes a, well, value to receiver is not actually a type. What's the type of it? Value. So value of takes a value. And then what is this thing? Where do I go to see what that is? Up to this record I defined up here. Access token symbol. Okay. The second parameter looks like it might be a currency symbol. Yeah, Justin, you got it, right? And then a name, a token name. And then what's the output? What do you think the output of value of is going to be right here? Yeah, you got it, Justin. It's an integer because look, this whole thing is wrapped in these parentheses. Okay, and fine, they're redundant, whatever. But what we're able to do is now we're able to compare the output of this value of function to a simple integer right here. Now, actually, it would be probably better to write this as a helper function. And when we start rewriting this thing for V2, that's exactly what you're going to see. Let me just show you the draft of this script over here. And what you can see is, I didn't do it here, but what I want us to do is start. Oh yeah, I did do it here. Yeah, tokens to withdraw. So I replaced in the next version of this that we'll eventually look at together. I replaced all of this in the output has access token function with a helper function that has a different name. But look, in order to do that, all I need to do is create something that has a type integer, and then I just cut and pasted that line right there. And now I can use tokens to withdraw exactly like I was using this whole line right here. But I just want to go on this journey with you and kind of be thinking step by step about how you might first write, you know, some ugly line that looks like this, and then later think about refactoring it. Let's take a quick moment to look in the documentation for value of. Value of, and indeed, here it is, value, currency symbol, token name, integer. Okay, so in any bucket of value, remember, I'm just doing this with the value that's being sent to a certain pub key hash, but if you wanted to just check the total number of tokens that are in a given transaction, you could use this function as well. Yeah, here. Oh, thanks. It looks like A got it too. Thanks, A. Sorry, I just have some invisible Zoom windows blocking my screen right here. All right. So what I really want to focus on today is what's the solution to a problem like this. And the reason this was a problem in the first place is I was trying to write a contract that allows us to see how much we can do without Datum and Redeemer. And the truth is, there's a reason Datum and Redeemer exist. They're actually really helpful tools. Okay. So as I was thinking about alternatives to this lazy approach right here, and having the ability to identify the pub key hash of whoever's trying to get some funds from this faucet, I couldn't really think of an elegant way to do it without now starting to use these other tools, Datum and Redeemer. So here's my next question for you. You might still be pretty new to these two things, but what do you think is a better tool for the job of identifying the pub key hash of somebody who's trying to interact with a contract? Would this be something that the Datum takes care of, or something that the Redeemer takes care of? Anybody want to venture a guess? Datum could have some pub key hash in it, but so could a Redeemer. I can put arbitrary data in either one, in either the Datum or the Redeemer. In fact, I can create new data types, and I can use them in each of these. We're actually going to see when we start looking more closely at the Bounty Treasury and Escrow DApp, which has two contracts in it. You're going to see that we use the same data type as the Datum in one of those validators, and we use the exact same data as the Redeemer in another validator. And that opens up all sorts of new opportunities. And Justin, you're getting the idea, right? Datum is going to be locked on chain with the UTXO. That's the critical point. If I lock any funds at a contract address, I got to include some datum on it. But who's doing that locking and who's doing the unlocking? In this case, I've got a pool of tokens.
Is it not default?
Go. Sorry.
No, that was it. I think there might be some delay on my end. No, I was just saying, wouldn't it be defined by the logic and other variables, or constants maybe in this case, like TTL, etc.
Okay, so right, these are there's going to be software mediated processes that define the Datum and the Redeemer on either end, right? And so it's less about thinking about what we might eventually be able to write code to do, right? We can automate all of this, and to build a functional DApp, you have to. But still, the critical distinction between Datums and Redeemers is that when tokens are locked in this faucet, that's going to be done by whoever is funding the faucet. It's going to be me today. I'm going to put some tokens in here and invite you to try to unlock them. And I don't know who's going to try to unlock this these tokens. So I can't place in the datum that gets locked with the UTXO the pub key hashes of whoever's trying to unlock. I would have to know the future in order to do that. And so this is why actually Redeemer is going to play the role here of providing the pub key hash of who's ever trying to unlock some data. And this pattern is pretty comprehensive. It holds across use cases, okay? The locker, whoever's locking something up gets to place some arbitrary data in the datum. Then at the time of unlocking, if the party trying to unlock the UTXO is going to provide any data whatsoever to feed into that contract and try to validate the logic, that's always going to come from the Redeemer. Whoever builds the lock provides the data for the datum. Whoever comes and says, hey, I would like to unlock that, provides the data in the Redeemer. And so what we're going to look at right now is an updated version of this contract that takes, instead of an integer with no purpose as the Redeemer, it's going to take a pub key hash as the Redeemer. And you can see this, these changes are pushed up to the live repo. I have a different version of this faucet validator script called faucet validator script with PKH, pub key hash. And so let's just look at the signature for this thing again. Takes the same faucet params, that hasn't changed. In this case, actually, datum is still going to be irrelevant. We don't care about it. But we're going to pass to the Redeemer some new data type, and we're going to call it receiver here. What is faucet Redeemer? It's just a new type defined right here. And all it is it has a sender pub key hash, sender PKH, which must be a pub key hash. And what this allows us to do, this is just way more realistic in the first place. This was kind of an artificial version of this, because once again, I wanted you just to grapple with what we could do without datum and Redeemer. And we saw the limits of that right here. But this is a much more realistic example. When somebody comes to unlock funds from a faucet contract, they have to provide a little bit of information. They have to provide the pub key hash of the address that they're trying to unlock to. And then we can use it. Look, here's this same design pattern we saw with access token name faucet. And instead, we're seeing sender PKH receiver. Sender PKH is the only record field that we have right here. And so we say, hey, get me the sender PKH from that instance of that faucet Redeemer type. From here, pretty much all the logic is the same, because look, this is one way to define a receiver pub key hash. And this is replacing this bit right here. But once I replace that, the rest of the logic can still hold. I want there to be a certain value paid to that receiver. Yeah, exactly, same thing. Questions or thoughts about that bit? Yeah, A.
Yes. So in the edge case scenario where, well, first, I always sort of, I suppose maybe rightfully the assumptions, datum being like a data store, and Redeemer being like the agent, which is a bit more flexible and able to sort of do the running around. But yeah, in the edge case of say for example, you already know addresses, whether it's a number of folks who currently have, say, a particular asset, or even something like, I don't know, like I read the CBDC paper from IO. There are going to be situations where you need, or reading, I skimmed it. There are going to be situations where there are going to be some actors who want to only allow for certain addresses, say, to be able to do certain things. In that case, I'm assuming then, from a logic standpoint, you could then just have those live within the data without sort of having to have them be defined by someone coming in, and then that handled by the redeemer to then fetch the public key hash of the addresses, kind of thing.
Okay, this is all related also to Justin's question here. So he says, does the unlocker not need anything in their data within the transaction? And so let's tie A's point to Justin's question for a moment. It's specified that datum must be an integer in order to interact with this contract. Okay, so actually, even though none of our validator logic takes that integer into account, it's not actually used for anything. If you don't include a datum that is an integer on a UTXO that you're locking at this contract address, it will not be unlockable. The validator will fail. So I could write hello world as a string as my datum, and I would effectively be forever locking those funds because I would not be able to validate, because there would be this type collision right here. Additionally, even once it is an integer, whatever integer is used at the locking step must be used at the unlocking step. So in order for me to lock anything in this faucet, I'm going to have to choose some arbitrary integer and hash it and include that on the contract output. And then anybody here who wants to unlock those funds is going to have to know what that integer was. But that's not the same thing as security, right? We could say, oh, it's a secret, but guess what? If there's real money behind it, as soon as there's a secret that you can use to unlock actual tokens that have actual value, that secret is obviously going to get out, right? And in fact, it's just an encoded, hashed bit of data. You can guess that. You can do a brute force attack on datum and try to match it. Okay, so datum, it should not be used as the combination lock. Because if you try to use it that way, even though it's tempting to do so, somebody's going to figure out what the combination was if there's enough value locked there. So to bring this back to A's question, well, what are some maybe other ways to gate access to a contract? Is it okay if I reframe your question that way, A? Right? And that's the other thing that this validator is doing. Nobody who doesn't have the PPBL Summer 2022 token is going to be able to unlock this thing. One way to gate access to a contract is to keep a list of pub key hashes. We could just hard code a list of pub key hashes into a contract like this. We could just save that as data right here, hard coded as Plutus, and then we could just check if somebody's pub key hash is an element of that list. We could do that. That's not dynamic. I'm sure maybe there's use cases for that, right? But anytime you change that list of pub key hashes, the contract address is going to change. It's a little bit like multi-sig, isn't it? So there definitely are use cases for that. But if I want to gate access for some future that I don't know all the details of, this is where the value of tokens come in. And this is right. I mean, all of us, our entire industry is just starting to really appreciate what a token does. And if I can do this for one token, let's just quickly look. It's actually, this is the one. This one right here is just checking that that token is part of some output, which you could argue is sufficient, right? If I'm checking that it was an output, it must have been input from somewhere. But we also check that it is an input. And the way we do that right here, input has access token. It's pretty simple, right? All we're saying is, look, get a list of all the tokens, right? All of the currency symbols that are part of this transaction, and then just check if this one is an element of that list. As long as it's part of the input, okay, we passed this test right here. Notice that this logic doesn't account for where that token is coming from. So it's all, you could say like this is actually redundant, right? In order for this, again, to have been output, it must have been input from somewhere. And if this function right here is not even checking where it came from, what good is it really doing anyway? But again, I want you to see this logic here and then start to think about how to use it or improve upon it. But that's the critical piece, right? We can gate access with a token. And if we can gate access with one token, we can gate access with any set of tokens. Maybe to interact with a certain contract, you need a whole cocktail of tokens, right? You need to have gotten this one over here and that one over there, and you got to have an unsig too. And once you have all of those things, now you can interact with this. And I'm only half joking when I name some NFT project. Every NFT project that currently exists, anybody can use those tokens to gate access to anything they want. I don't have to be the creator of Space Buds or Claymates or whoever, the what else, to use those. That's crazy. All of these assets that have been minted, anybody in the world can choose to provide some benefit to holders of those assets. That's another thing that blows my mind. I think that's fascinating, and we don't really know the full story of what that means. When anybody can say that anybody else's tokens or credentials matter here and there, some interesting things that could start to happen.
But also possibly the inverse there, right? When you start to think of blacklisting and that kind of thing. Yeah.
Now, so what role does datum play? What's the darn point of having datum in the first place? Well, you still have to collect the appropriate datum, right? Here's, a data object can be this complicated, but it can also have, you can have an arbitrary number of fields in this record, and then you could make a datum out of that. And wherever you're building your transaction, imagine a front end, you have to collect all of the appropriate datum and put it into one object just to have a valid transaction in the first place. And then as another layer, you can then use that datum in your logic, which we're not doing here, right? Once again, underscore, we're not using datum at all. But any data that's in the datum can then be used in your arbitrary validation logic. And that's really cool. And so going back to Roberto's question, did we really need to write a parameterized validator here? Not really. We could just write a single faucet contract, and then we could lock up any number of different UTXOs there. each of which holds a different token. And if we did that, the way we would identify which UTXO is holding which token, that would be a great role for Datum to play. Augustine, I hope you're just retiring for the day and not forever, but if it's forever, congratulations. We're really proud of you. Just kidding. See you soon.
When you say sorry,
No, go ahead. Go ahead.
when you say identifying the UTXOs, do you mean the like OREFs to get like unique identifiers? Is that the
Ooh, okay. OREF is a very important function when we're working with the PAB, for example. And it can be used in this kind of on-chain validation piece, but what OREF points to is a broader idea that's really important, okay? OREF does exactly what you just said, Roberto. It allows us to figure out which UTXO we want to be trying to interact with in the first place. And so think about this for a second. When I look at Cardano CLI and I look at all the UTXOs at a contract address, I can see all the datum hashes that are attached to those UTXOs. If I know that I'm looking for a particular faucet asset to unlock, what I can do is I can write my datum in JSON format. I can hash that datum, and I can see the datum hash. And then I can just look through the list of UTXOs and I can see, okay, which one of those has the datum hash I'm looking for? That's the one I'm going to look for. And in fact, that's exactly the logic that we use in a front end. Okay, so whether we're talking about OREF and doing exactly the logic I just described in the PAB, or we're talking about doing transaction orchestration by any other method, for example, in a front end, this is a very powerful feature of Datum, right? It's what's the word I'm looking for? Deterministic, right? How you get the datum hash for some set of data. If somebody can replicate that datum as a way of saying, oh, I want to get this token out of that contract, they create that. And then when we query the blockchain, I might write like a Koios query that says, give me all of the UTXOs at that contract address. And then I can say, just in my JavaScript logic or whatever language you're writing in, you can then filter that query result by datum hash to get the UTXO that you want, and then try to unlock that one. What do you think?
I sometimes have a hard time just in my mind keeping the whole logic together. I don't know. It's so easy when you think about server and the whole front end back end thing, but somehow when it's blockchain and on chain and off chain, I get a little bit lost in the sauce there. But yeah,
there's a brand new layer. There's a new layer we all have to wrap our minds around, and we have to figure out where it fits. And so, yeah, I said everything. I'm gonna show you by example everything I just said, over the next few lessons. Yeah, because that's a critical thing we got to look at. And I know that just saying it out loud like this without a visual is a bad way to teach. So that's just a coming attraction of something we'll do really soon.
Okay, awesome.
Hey, what do you think?
Yeah, so just to sort of take a few steps back from a validation standpoint and sort of some assumptions here, the way UTXOs or just the architecture is designed, and the way wallets or the wallet experience and UTXOs as well are designed, the idea here is to be privacy preserving. So the assumption here is that in terms of actually understanding what assets are in a particular environment, unless a wallet has a staking key then you can't really be able to figure out what other assets are within that wallet, even across different addresses, right? Again, this is just like from my current understanding of I might be sort of getting some things wrong here. So that's kind of one aspect of it. So if you don't have a staking key, then basically all the addresses within the wallet, one cannot be able to tell whether
That's all one wallet.
yeah, exactly.
Exactly. Yep.
Okay, so that's one thing, and then but an alternative here is to have assets inside enterprise addresses, which by default like don't have, you can't have a staking key, which means then like things like explorers or pool PM type environments can't be able to like show like, hey, here are all the assets which are inside this thing. So in this particular case with the validator, what we're looking at is the inputs which actually come in, right, which are explicitly defined. This person is saying, hey, here are a bunch of inputs of stuff that I already have. I'm assuming then maybe another layer here would be maybe tapping into like staking key or sort of, again, as you said, like a query, whether it's through Dandelion or, any other way of doing this, like utilizing the staking key to be able to figure out whether whether this person who's asking for this particular thing has all these other things of all these other assets within their custody kind of thing, within their wallet. And maybe there are other ways in terms of thinking about this, but I'm just trying to think of like the privacy preservation and also how validation logic kind of works. And yeah, and the fundamental nature of a wallet, I suppose. But yeah, I just wanted to
Oh man.
talk my thoughts out loud there.
Yeah, thank you. Well, here, right, we haven't even touched on the Plutus functions that are related to staking credentials. That's another thing. If you go back to the documentation and you look at that TX info type, there's a whole bunch of other fields related to staking that we haven't even talked about yet, right? It is, I'm glad you raised that point about kind of looking at the wallet as a whole collection of addresses and the role a staking key plays in kind of seeing that whole thing. That's important, and yes, that will be relevant. And just to kind of set us up for starting to move in that direction, it's trivial to write a query that just says, hey, show me all the addresses that hold this asset. That's very easy to do, and that you can already find that in the front end template, okay? But you're exactly right. To know which of those addresses are part of the same wallet, that's a different level to get to that point. And one answer to that is staking credentials. That's right. Okay. So cool. I hope that we are kind of setting ourselves up to dig deeper and deeper. And if anybody here is looking for something to do, right, that's an example. What I just said, go start learning about how staking works with Plutus. That's a wonderful course of study that would be time well spent. I want to honor time. We are at the official end of this session, but what I'm going to do now, I'm just going to keep rolling on this recording, and I'm going to lock some funds in this new version of this contract here that has the faucet redeemer and takes a pub key hash this way. And then I'm going to demonstrate how to unlock funds from it so that we can use everything after this point in the recording as a lesson video that anybody who's not here right now can look at in the course. So I'm going to chop the video right here, and everything after this point will be posted on Canvas as kind of an assignment module so people can go try to unlock from this faucet. But if you want to stick around, do it live and ask questions. It's really fun to have company here. So if you got to run, see you soon. if you're still here, this next part should take, let's see if we can do it in 30 minutes. If I say 30, that probably means it'll take like 55, but yeah, that's how it is. So let's see how this goes. So I've got this thing. And one thing we didn't really talk about is like, okay, well, where do these values come from? I hope that you've already reviewed some of the other lessons and you know that the actual values of each of these fields is set at compile time. So we're going to take a quick look at the compiler. And it's this one, yep. And so here in this version of the compiler, notice that I'm importing the validator script that we were just looking at. Faucet validator script with PKH, that's this one. And it's a good idea to use this feature of Haskell if you have a long, some long name for an import. It's good to rename it like this. I didn't do that here just because I want things to be really explicit for everybody. So you can see everywhere I'm using faucet validator script, using that validator, I'm using those faucet params, and then even within the data object, these ones. Lucas, see you soon. So that's imported and then it's used here. And if I was writing this code, more seriously, I would write like as FV or something, and I could replace this with FV. Okay. But for now, we'll just keep it this way. And I have set this up so that I can use the new access token and the new faucet T gimbal that are on pre-production. And so let me just zip back over here for a second. Query tip, query UTXO, testnet magic 1, add address, wallet 1. All right, so look, this is this token right here, 748EE with name 5050. That's PP, BL, etc. That's the access token, 748EE. And then the test gimbal FB45. That's this one right here. Okay. And 7467, that's a T gimbal right there. Make this a little bigger. And just let me know if I need to make the font even bigger here in my terminal. Okay, so what I want to do is lock some of these funds at the contract address. And I've got some notes that are in a README that are already part of the live repo as well. So you can get all of the notes I'm using right here if you have this PPBL course 2 repo. I'm in project 301 on the README. So I can build an address, just change testnet magic. And I've already done this part. In my output, I have a few different ways that I've played with this thing. This is the one we're using right now. And so this right here, this is going to be the address where I'm going to lock these tokens right now. So let me put that in the README. So we've got it. Contract address is this. You can use sender and sender key. I think I'm using wallet 1 and wallet 1 key today. Let me just make sure that's set up. Wallet 1. Yeah, I've got my keys set up. So I'm just going to change where it says sender here. I'm just going to change that to wallet 1 because I've already got that set up. Wallet 1. Okay. Then I'm going to go back and set these other variables here, and then I'm going to build this locking transaction. Let's just read through this for a second. I am still on Alonso era. If I was on preview network right now, I would write Babbage era, but for pre-production and for mainnet, it's still Alonso until the Vassal fork. I'm using two separate TX ins because I've organized my wallet, as we'll look at in just a moment, so that my extra tokens are in UTXOs that have a limited amount of ADA in them. And I'm going to need another UTXO that's just pure ADA to make sure that fees are covered. Where am I sending things? Well, I'm going to send to the contract address just a minimum amount of ADA. And let me send more than 12,000 of the asset this time. Let me lock 300,000 of them. And then I've got this datum hash. Now, remember from a few minutes ago, this datum hash has to represent an integer, and it does. You can calculate the datum hash for any data by using this command on Cardano CLI, transaction hash script data. And there's a few different ways to pass data. One of them is just to write a primitive value like an integer, and you'll get the hash for that. So anybody who wants to unlock this, any funds from this faucet is going to need that datum hash. And again, just to put another point on this, we could say that this number is a secret, but if there was any real money behind this secret, you know how fast that secret would get out, right? And there's nothing really hiding it from anybody. Okay, so there it is, but you do need to know that number in order to unlock here. What are we locking? We're going to lock an asset. And
Sorry.
Oh God, yep.
So could that value be parameterized? Could that that number could that be like a single number for like each one, and that could be secret? Okay. Awesome.
Well, I mean, it still couldn't be secret, right? But I could say, yeah, I could say that, hey, Roberto's token is locked at value 1, 2, 3, 4, and A's is locked at, I don't know, what number would A choose? It's hard to know. But right, we could all use whatever number we want. But even more than values, instead of using script data value, here, let me show you this. Let's just drop this command into the terminal. Right, so script data value is one thing I can do, and there's a message down here. There's no schema, almost anything is supported, including top level strings and numbers, right? So that just gives us a lazy way to play around with things, and it's certainly simple, okay? 42, that makes sense. But right, the other thing you can use is you could use a whole file, right? So a whole JSON file, and for this, there is a strict schema. But following that, this is much more useful, right? To write a data object, and in that data object, we could put things like the policy ID and the token name and how many tokens can be unlocked. Not that those would by themselves stop anyone from doing anything else, but they would just identify the UTXO as belonging to this particular faucet, and then we could use those values in a validator. And so again, the reason I wanted to start writing this contract like this is I think that what's here so far provides anybody who wants to learn by doing with a really nice template to try to implement what I just described. Try to write a version of this contract that actually uses a more interesting datum, which we can then name an instance of, and then we can use that in our logic, right? What if the access token symbol was not coming from a parameter, but it was coming from a datum? You could do that, okay? And I absolutely recommend trying that if that's something you're interested in and you have the time to do it. Okay, so I want to be in the README. All right, so I got this datum hash. Yeah, it could be any number. I'm choosing to use that one. I have this contract address here. And let's bring this over to the terminal as well. And let's query it. Because one thing to notice here is that there's actually already a UTXO here at the contract address, just because I was playing around with it yesterday and I was trying to get this working on the front end. And we're one step away. Cremo's troubleshooting one thing we discovered this morning, but very soon we're going to be able to do this whole thing on the front end as well. The reason this is important is because we have a pretty unique case right here where my goal for this contract is to keep it so that there's always just one UTXO there. And so I don't want to just send a new UTXO here and ignore this one. I actually have to do something special right now. I have to take this as input as well. And then I'm going to relock it at the contract address. So we end up with just one UTXO. And that'll make more sense as we do it. But the first time you lock funds at one of these faucet contracts, you won't have to worry about this step. And this is irrelevant to your unlocking exercise that you'll have a chance to do. But it is something that I have to deal with right now. So I'm going to grab this TX hash right here. And I'm going to switch back to my editor in just a second. I'm just pasting this first, index 3. Okay. So back over here, I need to use this contract TXN as another one of my TXNs. All right, cool. Now I have to recognize that this TXN is from a contract address. So I'm actually going to have to unlock it in the very same way that you're going to have to when you go and try to pull some funds from this thing. Okay, so the answers to this exercise, I'm about to show them to you right here, embedded in a bigger transaction. So let's think about this. When I build a transaction where I'm trying to unlock from a contract, there's a few other things I have to add. And maybe I haven't memorized those yet. And so I'm going to switch back over to my terminal. And I'm going to write Cardano CLI transaction build just to remember. Let's see. TX in. Oh, I'm going to need a script file. Yeah. I'm going to need some data. I'm going to need a redeemer. All right, let's get all of those things. All right, so over to my transaction build, TX in script file, TX in datum, value is enough, right? I hash it on the output. The output gets the hashed version of the datum, but the input, I can just write the number. All right, that one's easy. 168. Okay. And then I'm going to need a redeemer. And in this case, I'm going to use the file. And I'll show you what that file looks like in just a moment. And if I have the script, the datum, and the redeemer, that should be sufficient. All right, back over to where I'm drafting this transaction. Okay, I'm going to need 2 TXNs from my wallet, actually. All right, And I'm looking once again at my UTXOs here. So I have a UTXO that has 450,000 test gimbal tokens in it. That's going to be this one. Okay, I'm sorry. I know I'm not sharing my whole screen right now, but I'm just looking at the CLI to get that UTXO. And then I need another one that has just a bunch of ADA in it. 10 should be sufficient. So I have another UTXO here that has sufficient ADA to cover all the fees. Any questions so far? All right.
Yeah, just a quick one. This has all somewhat perplexed me. I remember way back in incentivized testnet days, it was a thing, and then TTL basically, and then it ceased to be a thing, and then apparently it then became a thing. So I'm looking at, the building section. I don't see any TTL calculations happening here. I'm assuming that either it's not a thing anymore on testnet or mainnet, or maybe I don't know. Yeah.
I'm really looking forward to, like, in the year 2035 doing some cast.live episodes where we talk about remember when, but we can already do it here. See, these are once
Exactly.
again, we used to have to walk through the snow barefoot for 17 miles just to learn Plutus stories, right? But no,
Back in my day.
back in my day, we used a function called build raw, and you actually had to write a whole transaction just to calculate a fee. And then you had to figure out with a calculator. You actually had to do it by hand. You had to figure out what the fee was going to be and what the output was going to be, and TTL and all this other stuff. And thank goodness that software gets more abstract over time, right? So that, yeah, there's a build raw still exists for anybody who wants to beat themselves up, go play with it. But luckily there's a new function called build instead of build raw that does take care of a bunch of stuff for us. It was, it's actually kind of sad that this was one of my most exciting days of the last year, but I was very excited when I found out about change address just being this thing that we could now use. You used to have to calculate down to the precise Lovelace how many tokens were going to each output, and then you always had to make sure to send the rest back to some address. And that's all just taking care of us for us now. Thank goodness. That's amazing. Now we still have to do the arithmetic with tokens other than Lovelace. So there's still some of that here, and maybe a future version of Cardano CLI will have a function that where change address can just take care of any number of tokens, not just Lovelace. But still, this is a pretty good step here. And the fact that we don't have to calculate the fee ourselves is absolutely a huge time saver. Okay, but enough reminiscing. Let's get this thing to work. What I got to do next, let's see, I need the path to the script file. And I typically wouldn't need this part, right? Once again, to reiterate, in an initial locking transaction, this step is usually not going to be part of things, but I'm actually doing an unlocking transaction and a locking transaction at the very same time. Let me just I could have grabbed these from here, whatever. Let's just paste those here because they've already got the variables. So I'm going to want a file called redeemer.json. But again, the name of this is arbitrary. You could call it anything. The Plutus script file that I just compiled, I'm going to want the path to that. Let's get that. It was this one. Uh-oh. My mouse just went here. I gotta stop sharing for a second. Zoom just gave me a headache. Let's try that again. Okay. Copy the path to this one and drop it in here. All right, so I got the path there. The asset that I'm locking I'm just going to copy and paste from my UTXO view. So I'm just grabbing that from off screen. Here it is, right? Policy ID dot token name. This is the T gimbal. Plutus script file is taken care of. Let's make that Redeemer file. In the interest of time, I'm not gonna talk through all the details of this Redeemer file right now. I'm just gonna show it to you for now, but it looks like this. So it's JSON format. It's a JSON file. We have a constructor. This is going to be a valuable tool when we start to understand that redeemers can specify actions, but for the moment, we can ignore it. And our redeemer has one field. The field for our redeemer is a string, and we use bytes. In general, we're going to use byte string, okay? Now, what's nice about pub key hashes is that they're already in this format. But if you had a string like hello world, you would have to convert it to a hex string first in order to be able to use it in a redeemer like this. But I've probably gone deeper than I wanted to already, okay? When you try to unlock from this contract, you can just copy this as a template. I will provide it in the notes, and you'll just replace my pub key hash with your pub key hash, the one that you're trying to withdraw funds to, okay? I'm just going to copy the path to this file. I have it in the transactions folder. Let's go to that folder, because then I can just use that file name. Transactions. So there's a bunch of other drafts here, but the redeemer is in this folder, and that is the one I want to be using. So that's great. Cool. Let me just double check that that is the one. I'm using pre-production wallet 1. Yeah, good. Okay. So I got the redeemer. Okay. Now I'm going to send to the contract address. I want to place 300,000 ADA there. I'm using a TX in that has 452,000 ADA there. That was the output of the last time I tested this thing. And so that means that I can withdraw to wallet 1 the rest. And what's the rest mean? Well, I've got wallet 1 and I've got contract address. The contract has 9,000 test gimbals in it. The UTXO I'm using has 452,000. So 461 total. If I'm putting 300,000 at the contract, then I should be getting 161,000 back to my wallet address. Now let's go back to the validator for just a moment here. This is precisely the case why I didn't use an equal sign right here. I said that the receiver has to get at least the amount of tokens specified in the withdrawal amount, which is, if we look at the compiler, 3,000. Okay. But the reason I wrote greater than or equal to sign is for cases like this, where I want to be cleaning up my contract or managing it, right? This gives me the ability to say, okay, well, if I want to consolidate UTXOs, I can still do that. There is a guard down here that doesn't allow just anybody to go and take as much as they want out of a faucet, right? Because what we do, and this is another one of those cases where all of this logic should probably be written as a helper function. But for now, you can see the faucet contract has to get the number of tokens that it had in the input, take away the withdrawal amount, and that amount can't exceed the amount that we're sending back. And so that allows us, that's just the guard against somebody taking, 10,000 just because they hold the access token. Kind of long-winded explanation about why we're able to get away with this right here. Okay, and then we'll send the change back to the wallet. Do I have a protocol file called preprod yet? Yeah, I do. I have, now that there are all these different networks, I no longer am naming my protocol files just protocol.json because I would lose track. So I've been just naming each of the different protocol params files by what network they represent to save future time. All right, this thing should work. Just kidding. I already know it's not going to work, but does anybody know why? Let's see. I'm going to show you something. All right. All I'm doing is I'm pasting all those variables right there. So now I can use them when I build this transaction. And did anybody notice the bit that I ignored here? I pulled in a bunch of gimbals. I pulled in enough ADA to pay for fees. But there's another thing that this contract expects that I have not yet accounted for. And we're about to see a Plutus error message right here. Let's see. Oh, that's a boring error message. Yeah, I forgot to set collateral. Okay. Good. Let's do that. We'll get to the better error in just a second. Right, because I am unlocking here, I need to have collateral specified. Anytime you want to unlock from a contract, you need a line that looks like this. And I forgot to add that TX in collateral. Let's just do that here. And I recommend just having like a UTXO that you can always be using as collateral. I have one with 5 ADA in it that I'm just never going to actually spend. And so let's grab that. And drop that. All right, let's try this again. But now hopefully this time we'll get a more interesting error. Collateral. Let's try it. Ready? Okay. Now I also, speaking of the old days of Plutus, when we started building Plutus transactions, we were not able to actually see the messages that we wrote in our validator code. It would just say, hey, that thing failed, and it wouldn't tell us why. But this was another exciting day when the script debugging logs were added to transaction build. And of course, there's this other thing that I did not account for. The input needs a PPBL summer 2022 token. So this is an easy problem to solve. All I have to do is grab one of these UTXOs and just add one more TX in to my transaction. So I'll do this all in the command line and talk it through as we go. I'm going to call this the auth token TX in. I'm going to set it to the value that's highlighted on my screen. Okay. Bring that over here. And then I'm just going to add one more TX in that has that variable name. So when I paste this build again, you can see what I just added here is another TX in. This one with the hash I just specified. And of course, it has that authentication token. All right, let's see if this one validates.
Does that token need to be balanced in the output?
It does. Look, I got another error. Good job. So let's add that. All right, so I can add over here. Now I could just include that in one of these other TX outs to myself, but to keep my wallet organized, my preference is to make them separate. So I'm going to send it back to my address again, just to Ada again, and then this time I'll add one auth. So, well, you know what, this one, instead of writing a variable for this, I'm just going to copy that asset string. All right. All this use of variables that I'm doing right here is just a preference. You can also always just write values here, right? All right. So Plutus once again gave us another error. In this case, the PPBL summer 2022 token must return to sender. And right, so yeah, it was placed in the input, but of course it has to be sent back to the sender as well. Let's do it. I'm actually surprised that we didn't get an unbalanced transaction error there. I think that's because of the order of my inputs and outputs. It looked and tried to validate first because it got to this validation line, all this stuff, before it got down to like looking at the actual outputs. But I might be wrong about that. Oops. All right, let's try this. There we go. All right, it's expensive. That's what, 5 or 6 times the fee of the lowest cost transaction that we could write. But still, for less than an ADA, we're doing a meaningful interaction. And this is going to be one of the huge benefits of Plutus V2. I'm really excited to see what this fee is when we're using reference scripts instead. And when we're able to look at, for example, an auth token input without consuming it and sending it back out. All of those changes after the Vassal hard fork are A, going to make our lives a little bit easier, and B, they're going to reduce transaction costs. But this looks good. I should be
In that case,
Yep.
well, just a quick one here. The additional, yeah, I suppose it's curious. The additional cost that I'm assuming would be incurred by maybe it's not really an increase in the data size, because if you've optimized the transaction itself, with things like reference inputs, then from a data standpoint it's cheaper, but from a computation standpoint, from what I understand, the computation also factors into the fee, so like it kind of offsets it. Yeah, but then it might be a bit more expensive, so I don't know. I'm curious.
We're still going to pay for computation, but alone, just not even including this script file is going to save us some Lovelace, right? So you're exactly right. The computation still has to happen, but at least we're not sending this data right here over the network every time we interact with the smart contract. Sign it, and I can submit it. And it's such a joy how blazing fast pre-production is. Another thing just to remind ourselves every time here, the only reason we're able to use this network is because somebody's running it. And I think a lot of nodes are being run by IOHK right now, but there's also some people who are choosing to run a pre-production node as a service to the community, and they all deserve a shout out. All right, so let's query those addresses again. And sure enough, we see a nice round 300,000 test gimbals here. We see the other 161,000 test gimbals in a single UTXO with just 2 ADA in it. We also see that this transaction hash here has an index of 1. There were 3 other outputs from this transaction. And you can see that all of them have precisely the same transaction hash. There's the one that sent the change back to me, just ADA. Now I used one of these UTXOs that had 10 ADA in it. Now I have 9.3 or so. I've got these 2 and those tokens, these 2 ADA and my auth token. And then I left 2 ADA at the contract address. So what questions do you have now?
Is there an IDE which has like a REPL where, like, as you're doing it, you're able to in real time see the errors, or is that
For transaction
not
building?
a thing? Yeah.
That would be really interesting. Well, it would need to, I'm not aware of one, and it would need to be live querying the on-chain data as you're writing the transaction, right? So if I paste a transaction hash into VS Code, it would have to automatically find that transaction hash and know what value is stored in it, for example. I mean, that would be a cool tool. That'd be interesting.
Yeah, cool.
I wouldn't be surprised if Kyle and the Cardano Sharp team have something to say about that. And he would, I don't want to show him the video from yesterday because he'd be mad to know that we weren't just using his tools to create multi-sig transactions, but we'll get him over here to talk about those soon. All right, so people need to know that the datum hash represents the integer 1618. And people need to know that 3,000 test gimbals can be withdrawn at a time. But of course, the last thing people need to know is they need to have a access token in the first place. So the last thing I'm going to do today is send a bunch of these on free prod. Okay. So now I have to scroll back up through the chat and just copy all of these over here. This part, I think I can still do this in 15 minutes and hit that goal of 55 minutes. But it's gonna take me just a few minutes to do this, and this won't be as interesting as the rest, so.
Hey, James, just
Hey.
confirming again. Unlocking also needs the script file, right?
That is correct. So I have to share the script file with you. Thanks for saying that. That's right. Thanks, Roberto. See you soon. And if anybody's dropping off and you need one of these tokens, just look for it at the address that you shared and it's coming your way. I need a script to copy and paste from a Zoom chat. Anybody got one of those? One, I'm seeing that you shared a NAMI address. That will not yet work for this. So I'm going to put that on hold. There's a few reasons it won't work, but the first and foremost is that NAMI is running on a different network than we're running this experiment on right here. NAMI
Yeah,
is-
I need to have it a production mode, pre-production. Yeah. I'm aware.
Yeah. You
I wanna
can
play with it.
you can open a pre-production account in Eternal, and I'll be happy to send you one of these.
Okay.
And then you're just gonna have to wait until Cremo and I just troubleshoot this last issue. We're trying to make sure we know how to write a good redeemer in that new library. Nicholas,
Got
thanks. Yep, got it. All right.
Thanks.
If anybody's catching up with this video later, I will need your address as well in order to share an access token with you. So just, you can either DM me on Discord or find some other way to reach out, but I'll make sure to share that information. Okay, so what do I want to do here?
Quick question here. It would be possible to say, create a multisig of all the folks doing PBL summer 2022, and that multisig basically be like a one of, I don't know, 15, right? Then that would, yeah, cool.
These are the kinds of ideas that it's so awesome when people are having them, and run with them. This is how we tinker, right? And I would love to see somebody take the lead on managing some, silly multi-sig address, and so we can run some experiments together. That'd be really, really fabulous. All right, so I got a bunch of receivers here, but other than that, this is not going to be a complicated transaction. So let me grab, I'll still use this as boilerplate, and then we'll just get rid of the unnecessary stuff. All right. So I am going to need I'm going to need 2 TXNs this time. One that has a bunch of those auth tokens, another for fees. I don't need scripts or contracts or anything like that. Data hashes. I'm going to make a bunch. Actually, this is a nice template right here. This is the template I can use. This is what everybody needs. So every receiver is going to get 2 ADA and 1 access token. One, two, three, four, 5. And I'm doing this right now. Remember, like when you see me do something like change the numbers 1, 2, 3, 5, and you're like, okay, that looks robotic. That's exactly right. I find that by building transactions this way, it gives me an intuition for what needs to be automated. And we're using like bash and transaction building as our pseudocode before we start building real orchestrators. Sebastian.
Thanks. In an unpredictable future, how do you establish the amount of collateral in the future?
Very good.
My
Right. There's an informal but kind of lazy and insufficient answer right now, and the answer is 5 is usually enough. But obviously, we want a better answer than that moving forward. And collateral is another thing that's changing. Okay, so with the Babbage era changes after the Vassal fork, people just won't have to think as much about their collateral the way it is right now. If I put 100 ADA up for collateral and I build a bad transaction, I lose that entire collateral. Post fork, what's going to happen is whatever amount of Lovelace might have been in my collateral UTXO, only the appropriate amount of collateral will be deducted, and the rest of the funds in that UTXO will still be returned to me. That's a really nice change, right? So it allows us to not have to worry about always making sure that we have a UTXO that doesn't have so much ADA that we would be pissed off about losing it. All right. 2 TX ins, 5 TX outs, and some change. Everything else here should go pretty easily. I just need to drop these receiver addresses in. And then I need 2 TX ins. For one of them, I need the one with all of my access tokens in it. So that's here at index 16. For my other one, I'm just going to use, I'll use this one that has this 9.3 or so ADA in it from before. Oh no, that won't be enough because I'm trying to send 2 ADA to everybody. Never mind. TX into, let me just use this big one right here. So those are my ins. I've got the 5 receivers out, and that should be sufficient to write a pretty simple transaction. Yeah. Oh, it's not valid. Yeah, I got to send the rest back to myself, of course. All right. So wallet 1, right? So even though change address takes care of the extra Lovelace, it doesn't take care of extra native assets. So I'm sending 5 of these tokens away from a UTXO that has 135. That means I got to send 130 back to myself. And we can see that the error does that math for me. Let me try this again. That works. All right. So even this one, you know, what is that? 0.03 ADA more than maybe the minimum fee, because there's multiple outputs here.
Sorry, man, in what line do you establish the return of the tokens? The rest of
the return right here, this one.
Okay.
All right.
Thanks,
The
man.
wallet 1 represents
Okay.
the
Of
wallet
course.
I'm using, yeah, and the rest of these. All right. And I can use the same sign and submit as usual. What did I say? Oh, I have the wrong file. Sign key, invalid argument 1.
I think you have the wrong TX body.
Oh, TX. Now I have the wrong name. Yeah, I made my newest transaction had an out file called TX lock. And then I was just lazily grabbing one that had a different file name for the draft. Here we go. This out file. I should have been more precise about that, but I'm not saving this transaction for anything. All right. So people should, in just a moment, have those tokens ready to go. My next step is to share with you. I will share the already compiled Plutus script file. It's just this bit of data right here. It's a small file. It's longer than the other ones, but like that's still not that much data, right? You'll need this file. You could try to compile it on your own for a challenge, but of course, like I said, I'm going to share this. You'll need the address, and you'll need the token that's now in your wallet. And you'll need to know that the datum value is 1618. But we should be good to go after that. As always, my advice when you start trying to build this transaction is once you get it working, before you sign and submit it, try to change a few things just to screw it up, right? Just so you can see the different error messages. And this might happen automatically if you don't see it the first time, but even after you get that transaction build working, try to make an unbalanced transaction. Try to make a transaction that has some datum value other than the value where these funds are locked, right? And yeah, it should be fun. Oh, you know what? There's and I didn't, you know what, I probably didn't say this sufficiently. So this is another thing people are going to run into. Should have thought about this. And it would have been great to have a little bit more time here, but in the unlocking transaction, in order to validate the contract, you are going to have to send the additional test gimbals back to the contract address. So you do still have to manage this part. And I suppose that anybody who you know, wanted to play a little prank on anybody could change that datum hash. You could. Okay, so try to make sure to hash that datum. I'm gonna have to write that in the docs as well. Because when we relock this UTXO here on an unlocking transaction, we have to make sure to relock it with that datum hash. This is a non-issue when we're using only a front end, because we can orchestrate the front end to do that for us, to always use that same datum. But in this case, we have to rely on each other to keep that there. And you know what? If somebody forgets that step, then there's just going to be some lost test gimbals on the pre-production network. But that too would be a worthwhile learning experience. Nice, Nelson got the token. Good, yeah. So if you check your wallet now, you should see that. Everybody should have the same transaction hash. And there we go. 15 seconds to spare. Cool. Thanks for staying late. Anybody who stuck around the whole time. If you're watching this later, of course, I'm sure you'll have questions, so be in touch. And we'll see what happens next. Thanks, everybody.
Thank you.
Anybody got last questions before we sign off?
Thanks, man.
My
No,
pleasure.
thanks.
My
Have a good
pleasure.
one.
Thanks for being here, Nicholas. Thank you. All right. Yeah, Nelson, I'm so glad we're finally here, man. Feels good to finally be talking Plutus and documentation with you. All right. Cheers, everybody. See you next week. And indeed, Mix, good luck, everybody. See you soon.
See you.